Hello students, now I am coming with a new video class of electrostat. Till now we discussed how to calculate force, initially force acting on point charges, then force acting on point charge because of a big size object or vice versa, meaning one point charge and one big size object discuss. Then there may be situation finally where you have to handle two big size object. So in that case, one different concept required, and that concept will help us in doing calculation. That concept I am going to introduce now. This is electric field. Electric field is a new concept, and this electric field will help us in doing calculation of force in big size object. We can do it easily by using the concept of field. How we will discuss one by one. First of all, what is electric field? What is electric field? It is I'm discussing again. Actually, once in my last video class, a point discussed. I'm just repeating it once more. So here one charge present. I am considering this is a charge. This charge I am considering Q. Maybe positive charge, maybe negative charge. I am just considering a charge. Because of this charge in the nearby region, here, maybe here, or maybe here, or maybe here, or maybe here, not in this side, in all side, here in 3 dimension. If you place any other point charge or any other charge, the other charge placed here gets affected by the original charge. Meaning, in the nearby region of this charge, in the surrounding 3-dimensional region, this charge can create influence on other charge. So what is electric field? Electric field is by definition is this thing. You write the definition first. Electric field, right. It is the region, meaning the space. It is the region around a charge up to which influence of the charge can be realized. Meaning, if a charge present, up to what distance you can identify influence of this charge, up to that we can say field of this charge present. Now this is field. Field present up to a long distance. Why? Because influence of the charge actually present up to almost infinite distance. Force is inversely proportional to square of the distance. So whatever influence, that also inversely proportional to square of the distance. Problem is, as you go to greater distance, automatically value of this influence, meaning the effect, will become smaller. So if you do calculation of field here, directly by definition it is the region, meaning the space up to which you can identify the influence. So this is not so important for us. What is important for us is at a particular point, maybe here, maybe here, maybe here, or maybe here, or maybe here, what is the strength of this field, meaning how strong the field is. So if you want to identify strength of the field, or how strong the field is, or what is the intensity of the field, we have to discuss one other term called electric field intensity. Symbolically it is E. It's a vector quantity, so you should put E over a vector sign over E. So what is electric field intensity? You write the definition first. Whenever you come to my class, you should be always ready with pen and paper, and you should go to my classes serially. Don't jump to any one class directly without looking at the previous one. Look at what is the definition of electric field intensity? Right. Electric field intensity, you write first, electric field intensity at a point is the force acting per unit charge, is the force acting per unit charge placed at that point. Electric field intensity at a point is the force acting per unit charge placed at that point. Or, you write or also, electric field intensity at a point is the force acting on a unit positive charge placed at that point. Electric field intensity at a point is the force acting on a unit positive charge placed at that point. Actually, both definition mathematically the same. How? Just let me explain. Say this is one charge q present. Because of that here, say one point P present, I want to find field at this point P. My aim is to find field at this point P. To find field at this point P, what we should do? Two options. We can consider here one unit positive charge, meaning 1 coulomb charge. That unit positive charge, unit of charge is 1 coulomb, so I am saying 1 coulomb charge, unit positive value is 1. So what is the force acting on this 1 coulomb charge? This is the field at this point. This is one way. If 1 coulomb charge is not available, we can do it in some indirect way also. Say, instead of placing that 1 coulomb charge, let me place a charge q, small q. This small q, which is used to test the value of electric field here or to identify the value of field here, is called test charge. Is called test charge. Now this q is the test charge, meaning the charge used for testing the value of field or to find the value of field here. This q charge, if experience a force F, not known here, I am just writing, say this q charge experiencing a force F, then we can write like this. For q charge, the force is F. For unit charge, the force is F by Q. I am using unitary method. So this F by Q is nothing but force acting on a unit positive charge. So ultimately same as this one. So by definition, force acting per unit charge is known as field. So field is F by Q. If you look at the direction, charge is a scalar quantity. So whatever direction of force acting on this test charge, that should be the direction of field. If you write in this way, mathematically the definition is not perfect. Why not perfect? Look at, I am considering a q charge here that are called test charge. Now there should be some special quality of this test charge. What is that special quality? This test charge should be very small in magnitude. Why? By chance this test charge is not very small in magnitude, because of presence of this test charge, the original charge gets affected. It may get repelled, it may get attracted, and if the original charge gets affected, because of that field also gets affected. So if you want to get field properly, then this test charge should be as small as possible, such that it is not affecting the field present there. So best definition is electric field is limit q tends to 0 F by Q. Electric field is same F by Q, but we are writing some property of this charge, this charge should be very small. So if you consider electric field at a point by considering a very small test charge, then value of electric field measured by you will be perfect. If you do the calculation of field at a point by any charge, clear, then because of the presence of that charge, that q may get affected, because of that value of field measured by you may not be perfect. Now come to this is electric field. Now how to use this electric field for calculation? Here one simplest kind of situation. Write a question first. Find electric field intensity. I am writing in symbol only, you have to write full. Find electric field intensity at a point, right? Find electric field intensity at a point at a distance r away from a point charge capital Q. You write the question first. Find electric field intensity E at a point at a distance small r away from a point charge capital Q. So what is the question? One point charge capital Q present at some r distance, here a point present, say I am writing P. Question is, at this point you have to find what is electric field. You have to find electric field at this point. Now to find electric field at this point, let me place a q charge here, and during the calculation this is taken into account. Say this q is small. then force acting on this charge will be 1 by 4 pi epsilon naught capital Q small q by distance r square. This is the force acting on this test charge. We assume the test charge is small. By definition, you have to write full. By definition, electric field is F by Q. I am writing the value first. F is this divided by Q, so it is 1 by 4 pi epsilon naught capital Q by r square. So this is the value of field at this point. Direction of the field, if you want to measure, just consider here one imaginary 1 coulomb present. Because of that Q, 1 coulomb gets a repulsion like this, so direction of field in this side. So direction of field comes from the direction of force acting on a unit positive charge, and value of the field is given by this relation. Look at, as this F by Q, F carries capital Q small q, and F by Q meaning value of field, if you want to calculate, it will carry one charge less than whatever formula used for force. In force, two charges present, capital Q small q, in field only one. So this is the field because of a point charge placed here. Let me extend this idea further. Clear? You may get some question of point charge. Simple. Say, I am just showing one question now. Say this is a combination of 4 point charges. So 1 plus q here, 1 plus q here, 1 plus q here, and 1 minus q here. I am just writing charges at my choice. Clear? Say side is L. Question is, say P is the midpoint of one side. You write the question first. Right. Figure shows 4 point charges. Placed at the corners of a square of side L. Figure shows 4 point charges placed at the corners of a square of side L. P is the midpoint. of the side shown. P is the midpoint of the side shown. Find net electric field at point P. Find net electric field at point P. Now look at the idea. I am showing the solution for you. Because of a point charge, just the derivation shown, the field is given by capital Q divided by 4 pi epsilon naught r square. Be careful, this measurement is done in air. If some other medium present, then with 4 pi epsilon naught 1 k, meaning dielectric constant required. Okay. I am finding field. At point P, there will be 4 field. One because of this Q, one because of this minus Q, one because of this Q, and one because of this Q. You have to calculate all individually. Clear? Field because of this Q will be in this direction. I am just naming the charges. It will be easy when you name it. Say this is charge number 1, say this is 2, this is 3, this is 4. So field because of number 1, number 2 charge is this. So field because of number 2 charge, I am writing Q by, this is charge number 2, by 4 pi epsilon naught L by 2 square. Side is L, it is L by 2 square. Now I am finding field because of 3. This is a negative charge. Third charge, whatever considered by me negative. If you consider any 1 coulomb, because direction of field is given by the direction of force acting on a unit positive charge. So this is a positive charge by definition. So this minus charge will attract it. So E, because of the third charge, also of same value, Q by 4 pi epsilon naught L by 2 square. Be careful, direction considered, their value same. That is why only value written, plus minus no need to write. Like force, plus minus to be used in the direction, not in the value. So these two in the same side. So total electric field because of these two, meaning 2 and 3 together, is their sum, meaning 2 into Q by 4 pi epsilon naught L square by 4. It is after simplification, twice Q into 4 by 4 pi epsilon naught L square. So finally it becomes Q by twice Q by 4 goes cancel, pi epsilon naught L square. So in downward direction. So because of charge number 2 and charge number 3, we completed the calculation. I hope no difficulty in that. Okay. Because of this charge number 1, this 1 coulomb will get a force like this. Let me write. I am writing it separately. One charge Q, one charge here. This is charge number 1 and this is charge number 4. I am doing calculation here at point P. Because of this one, field will be like this. This field I am writing F because of 1. Because of this one also there will be a field like this. This is F because of 4, meaning charge number 4. Both positive, that 1 coulomb there is a repulsion in this side and there is a repulsion in this side. So accordingly drawn. So what is the value of field because of 4 and field because of 1? Let me write. Field because of 1 and field because of 4 in magnitude same. Let me write. So I am writing field because of 1 or field because of 4. It is Q by 4 pi epsilon naught. We need this distance. Clear? What is that distance? Just let me tell you what is this distance. This is L and this is L by 2. This is L and this is L by 2. So if you write this distance, clear? I am writing this distance as say D. Clear? It is say D square. So what is that D? Let me show here. D is under root L square plus L by 2 square. So it becomes L square plus L square by 4. So it is root over 5 L square by 4. So it can be written root 5 into L by 2. So that distance D is a known thing, we can put here. Now look at. If you consider this E1 and E4, they are acting in different direction like this. So directly their addition not allowed. I hope no difficulty in that. Directly their addition is not allowed. So what you should do, say this angle I am considering theta. Then this side angle also theta. So if you break this E1 apart, E1 cos of theta here, E1 cos of theta, and a part here E1 sin of theta. Similarly this E4 going in this side, if you break this angle theta, so this one also theta, this is theta, a part in this side and a part in this side. This part and this part will go cancel. So if you write total of E1 and E4, meaning 1 and 4, then it is E1 cos of theta plus E4 cos of theta. I hope drawing clear. E will be in this side, this angle theta, a part cos of theta, a part sin of theta. E because of 4 in this side, a part cos of theta, a part sin of theta. Sin of theta part goes cancel. I hope no difficulty in that. Value of E1 and E4 same. Yeah? So you can write both value same. So it is Q by 4 pi epsilon naught D square. What is the value of D? We know D is this one. You have to square it. D square. This value same, so twice of this cos of theta. So twice q by 4 pi